Welcome to the Saving Energy in Process Steam Systems webinar. I am Mary Benson, and today I'm here with Robert Miller and Mark Bertram, and they'll be telling you about the process steam energy reduction projects that are supported by the Ameren Illinois ActOnEnergy program. First, I'm going to cover a couple of housekeeping items. I have all the participants muted so the webinar won't pick up any background noise. Today's webinar is being recorded, but as you can see, the participant names are hidden, and so no one else can see who is on the webinar. If you have any questions during the presentation, please type them into the chat feature located on the bottom right side of your screen. And also, after the session, I'll be sending you a survey, so please provide me with your feedback. And this webinar will last about 60 minutes. Now, before we get started, I'm going to give you some quiz questions, and if you could please put in your answers and submit those. That way we can find out about what you already know about saving money in process steam systems. And you will have about 1 minute to answer these questions. And the poll is open for you now. Okay, you'll have just a couple more seconds to get the rest of your results in, and then I will share the results so you can see what everybody answered. And I'm getting ready to close the poll. It's going to take just a couple seconds here, and then I will share the results. I'm not going to give you the answers now, but we're going to take the same quiz at the end to see what you learned, and then I'll give you the answers at the end of the session. So here I'm sharing the answers so you can see what everybody answered. And as I said, we'll go over the same quiz at the end. Now, I'm going to turn this over to Rob Miller, and he is going to tell you about today's topic.
Good morning, everyone. I am Robert Miller, a technical reviewer with GDS Associates Incorporated, an ActOnEnergy partner. First thing I'll do is introduce the topics we'll cover today. Today we're going to talk about best practices in process steam, the incentives available through the ActOnEnergy program, and how to get started on your project. The information presented today will help you identify process steam energy reduction projects and how to save money on your natural gas bill. Now I'll tell you a little about the ActOnEnergy program. Ameren Illinois ActOnEnergy program offers financial incentives to customers to be more energy efficient. Energy efficient upgrades not only lower your energy bills, they can also reduce maintenance costs, improve comfort, provide precise control, and extend equipment life. The Ameren Illinois ActOnEnergy initiative helps businesses use less energy and save more money. The ActOnEnergy programs include electric and gas incentives, where the incentive is paid to you after you complete the project. There are also energy-saving products available at the ActOnEnergy online store, where the incentive is built into the price. The online store is located at www.actonenergy.com/business online store. Now, Mark will tell you about the process steam system opportunity areas and what incentives are available to help you with process steam system projects.
Good morning, everybody. My name is Mark Bertram. I'm an engineer with GDS Associates and an ActOnEnergy partner. Just to give you a nationwide idea of process steam and how much energy it's using nationwide, you can see here that over a third of the energy used in the country is in industrial facilities, and then a third of that energy is process steam within industrial facilities. There are opportunities when you have a steam system to be able to reduce that energy use. First step in producing or in steam use is actually producing it. This diagram above shows a typical energy flow within the steam production system, similar to any furnace you'll have. Most of the heat is leaving the boiler as steam, although there's significant amounts that come through the exhaust flue and out the boiler blowdown, along with some miscellaneous radiation, insulation losses, and things. So keeping this in mind, when you're able to reduce the demand side, your energy use, your steam use, that's going to bring down your whole system energy use. But there's also operations on the supply side, the production side, where we have about 30% to play with and bring that down on your energy use. Once you get outside the generation, it seems steam systems can be broken down pretty easily into these four categories, going through the distribution and the use, and then recovery at the end. In industrial settings, there's a wide range of what the distribution systems look like, uses, and operating practices. So there's going to be very varied opportunities for process improvement and steam system improvement. Today we'll be running through a couple of these options, hopefully more globally, and specific. ActOnEnergy has incentives for more specific to your process that can be utilized also. So prior to jumping into individual incentives and opportunities, we'll just check to see if there's any initial questions that have come up. Mary, has anything come in?
Nope, I don't have any questions so far.
Okay. Well, then we'll move ahead to the number one opportunity with nearly every steam system is steam trap repair, replacement, monitoring to keep the system operating properly. Typically in steam systems where the traps haven't been maintained for 3 to 5 years, an assumption of 15 to 30% of the steam traps have failed. This is generally allowing live steam to escape into the condensate return system, where it's losing its energy as it comes back to the boiler, and that steam energy is not being used. In systems with a regularly scheduled maintenance program, the goal is to get the leaking traps down to less than 5% of the total population. If your steam system includes more than 500 traps or so, there's probably significant steam losses occurring throughout your system. Steam traps are tested to determine if they're functioning properly and not either cold plugging or failing in an open position where the live steam can escape. Essentially, there's 4 basic ways to test steam: temperature, sound, visual, and electronic. Each one has its benefits, either cost-wise or detail-wise. But essentially, what you want to remember is, depending on the pressure of your steam, as you can see on the screen, the higher the pressure, the more often you want to be checking your steam traps, because the traps will be, the higher the pressure, the more expensive the trap failure will be. That savings from fixing a trap can range from under $100 to several $1,000s, depending on the steam system use. ActOnEnergy provides also a range of incentives depending on your system, from $100 to $400 per trap. And typically, these measures are funded out of a facilities maintenance budget, and typical payback on the survey and fixing traps is less than 2 years. Opportunity number 2 is repairing the leaks in the system. As steam piping components fail, either be it by improper design, corrosion, and other reasons where you may end up with a leak in your system, the best goal to eliminate the steam leak, or the ideal way, or the idea behind eliminating the steam leak, is reducing the direct use of steam out of your system, where if it's leaking out the system, it's essentially using that steam up and it's not being returned back to the boiler. The makeup is completed using groundwater at 100, 200 degrees less. Steam leaks should be repaired as quickly as possible, and we don't have a recommended steam leak testing interval, kind of an ongoing, as you see it, fix it up. Generally, the safety concern of the steam leak is a driving factor in the repair. Energy loss can just help justify the immediate maintenance and expense of the leak. Steam leaks can be identified 3 different ways, either by sound, visually, or electronically. In some cases, larger leaks are not immediately repaired because it appears that it may be part of the typical operation. But for the most part, any leak is not a part of normal operation. So it would be, if you have something that you think may be a leak but looks like it may be normal, it's good to start asking questions and figuring that out. If you have an infrared scanner or ultrasonic equipment, that can also help you detect some smaller leaks, some things you wouldn't be able to see coming out. Similar to failing steam traps, the annual savings varies greatly between systems of leak, but types of leaks and the system operating procedures. It's a low-cost measure, typically out of the maintenance budget, and typically, again, it's a 2-year payback once you find the leak and can take care of it. ActOnEnergy has an incentive of $1.20 per therm, and you should use the custom application for any steam leak. Opportunity number 3 is improving your boiler combustion efficiency. Operating your boiler with the optimum amount of excess air will minimize the heat loss up the stack and improve combustion efficiency. Boilers often operate at excess air that is higher than optimum, a lot of times for emissions to make sure those stay in line, but also because as you go below the typical center point, your efficiency drops off pretty quickly. Combustion efficiency is a measure of how effectively the heat is turned into, or the heat content of a fuel is turned into the usable heat. Stack temperature and flue gas oxygen concentrations are the primary indicators of the combustion efficiency. The correct amount of excess air is determined from analyzing flue gas oxygen and carbon dioxide concentrations. Inadequate excess air results in unburned combustibles, while too much heat is then also being lost up the flue gas. Lowering the overall boiler fuel to steam efficiency is the result of essentially the heat loss, and periodically monitoring the flue gas composition will let you know when your boiler is in need of a tune-up. On well-designed natural gas systems, an excess air level of 10% is attainable. There are some expensive systems available on boilers that can complete real-time monitoring of excess air and combustion efficiency, and can detail the combustion efficiency down to within just a few degrees. Generally, if you're looking for a rule of thumb, the boiler efficiency is increased by about 1% for every 15% reduction in excess air, or 40-degree reduction in stack gas temperature. The tuning up a boiler, again, can range from several $100s to several $1,000s a year, depending on your steam production, pressure, and operating hours, and your controls available to complete that, the tune-up. Ultimately, it's a low-cost measure, typically in a facility's maintenance budget, and again can be paid back in 2 years. ActOnEnergy incentive is $1.20 a therm for this, and again uses a custom application. Opportunity 4 is insulating your hot surfaces. Uninsulated steam distribution and concentrate return lines are a constant source of wasted energy. Any source over 120 degrees should be insulated, including boiler surfaces, steam and condensate return fittings. Insulation frequently becomes damaged over time or is repaired, or pipe is repaired and the insulation is never replaced. Damaged or wet insulation should be repaired immediately to avoid compromising the insulating value of the system. Eliminating sources of moisture prior to insulation replacement eliminates the causes for wet insulation. Some other options where your insulation may get wet are leaking valves, external pipe leaks, leaks from adjacent equipment. Once that insulation gets wet and soggy, it really starts to deteriorate and doesn't have the same insulating value. The amount of heat loss due to inadequate insulation is a function of the surface area exposed. This is important in the pipe bends and valves and flanges and traps and other fittings. A 6-inch gate valve can have more than 6 feet of surface area from which to radiate the heat. Insulating a line and your valves and other components can have an annual savings of several hundred to several $1,000s $6 again, again depending on your steam system and the amount of area of pipe exposed. For spot repairs and small projects, it's generally a low-cost measure that can be funded out of your maintenance budget. You can see above in the upper picture, you can fix it with foam and duct tape, but typically you'll get better results from better materials. If you're looking for to kind of overhaul your whole insulation system, the cost does go up. It's medium measure cost and may require some sort of capital funding and some planning to get in there. But both smaller and larger projects can pay back in less than 2 years. ActOnEnergy has an incentive of $1.20 a therm, and you should use the ActOnEnergy custom application. Just a note before your next quiz question from Mary, the picture on the bottom boiler, the one with the insulation stripped off, actually had the highest tested combustion efficiency of boilers of that technology that I've ever dealt with. But with the insulation off, we still recommended replacing that boiler. I think it had a 4 to 6 year payback. Just a reminder how the system fits together. And now I'll turn it back over to Mary.
Okay, now I have another quiz question for you here. Do all ActOnEnergy custom projects require pre-approval? I'm opening the poll, and you'll have just a few seconds for this one. It's a yes or no. Okay, I'm getting ready to close the poll here. Taking just a few seconds. You'll have 3 more seconds to finish, and then I'll share the results. And here's the results. 56% said yes, and 18% said no, and 26% no answer. The correct answer is yes. All custom projects require pre-approval. So now I'm going to turn this back over to Rob, and he's going to tell you about opportunity number 5.
Now I'm going to tell you about more capital-intensive process steam system opportunities. The first is upgrading boilers with energy-efficient burners. A boiler will run only as well as the burner performs. A poorly designed boiler with an efficient burner may perform better than a well-designed boiler with a poor burner. Burners are designed to maximize combustion efficiency while minimizing the release of emissions. You want to provide the proper air-to-fuel mixture throughout the full range of firing rates without constant adjustment. Many burners with complex linkage designs do not hold their air-to-fuel settings over time. Often, they are adjusted to provide high levels of excess air to compensate for inconsistencies in burner performance. An efficient natural gas burner requires only 2% to 3% excess oxygen, or 10% to 15% excess air in the flue gas, to burn fuel without forming excessive carbon monoxide. Most gas burners exhibit turn-down ratios of 10 to 1 or 12 to 1, with little or no loss in combustion efficiency. A new energy-efficient burner should be considered if repair costs become excessive, reliability becomes an issue, or the energy reductions are significant. For example, consider purchasing a new energy-efficient burner if your existing burner is cycling on and off rapidly. Rotary cup oil burners that have been converted to use natural gas are often inefficient. Determining the potential energy saved by replacing your existing burner with an energy-efficient burner requires several steps. First, complete recommended burner maintenance requirements and tune your boiler. Conduct combustion efficiency tests at full and part load firing rates, then compare the measured efficiency values with the performance of the new burner. Most manufacturers will provide guaranteed excess levels of oxygen, carbon monoxide, and nitrous oxide for their burners. Annual savings can range from several hundred to several $1,000s, while the ActOnEnergy incentive for this measure is $1.20 per therm. This is a high-cost measure that will require capital funding. It can pay back in less than 2 years.
Okay, Rob, I do have a couple questions here for you or Mark, whoever wants to answer them. Are you ready for a couple questions?
Go ahead.
Okay. One person is asking, how are therm savings calculated or determined?
Therm savings be determined by doing a calculation for your current boiler, determining its energy usage for an entire year, and then you would do a calculation for what the new burners would use for an entire year. And we understand that's going to be more of an estimate than anything. Subtract one from the other, and that's your energy reduction for the year, and then you multiply that by $1.20 per therm to figure out your incentive.
Okay, thank you for that answer. And now another person has a question. Can all opportunities be requested on one custom application?
Yes, they can, though if you're going to be doing several at once, we would like to see the calculations done separately. That way we can follow each set. But yes, you can use one application for multiple projects.
Great, thank you. That's all the questions we have right now.
Okay, the next opportunity is cleaning boiler waterside heat transfer surfaces. Heat transfer surfaces should be cleaned periodically. Cleaning intervals depend on the individual systems and are based on the boiler type and amount of makeup water used. Boiler water sampling can detect fouling on the water side. Even on small boilers, the prevention of scale formation can produce a substantial energy reduction. Even thin layers of scale serve as an effective insulator and retard heat transfer. The result is overheating of the boiler tube metal, tube failures, and loss of energy efficiency. Fuel waste due to boiler scale may be 2% for water tube boilers and up to 5% for fire tube boilers. It is recommended that surfaces be cleaned at least once a year. Correct blowdown and water treatment will aid in keeping the water side surface clean. Insufficient blowdown will increase the amount of dirt in the steam system. An indirect indicator of scale or deposit formation is flue gas temperature. If the flue gas temperature rises, with boiler load and excess air held constant, the effect is possibly due to the presence of scale. Annual savings can range from several hundred to several $1,000s, while the ActOnEnergy incentive for this measure is $1.20 per therm. For smaller projects, this is a low-cost measure that can be funded out of a facility's maintenance budget. Larger projects will require capital funding. Both smaller and larger projects can pay back in less than 2 years. Next, we are going to discuss waste heat recovery opportunities. Heat losses are unavoidable in the operation of all boilers. Air and fuel are mixed and burned to generate heat, and a portion of this heat is transferred to the boiler and then to the water to make steam. When the energy transfer reaches its practical limit, the spent combustion gases are removed, exhausted, from the boiler via a flue or stack to make room for a fresh charge of combustion gases. At this point, the exhaust flue gases still hold considerable thermal energy. Additionally, boiler blowdown and condensate return also contain significant amounts of thermal energy. Replacing these losses should be a high priority for anyone interested in improving the energy efficiency of process steam systems. These four measures concentrate on recovering waste heat and reusing it, either at the boiler or elsewhere in the plant. Whenever possible, waste heat should be recovered. In addition to energy reductions, heat recovery also reduces water and chemical use of the boiler. Annual savings can range from several hundred to several $1,000s, while the ActOnEnergy incentive for these measures is $1.20 a therm. These are medium to high cost measures that will require capital funding. The paybacks range widely depending on the system and usage. Now, Mark will tell you about businesses that have completed process steam projects.
All right, we have two quick case studies here today. The first is a chemical plant. Although, there we go. Sorry, it took a second for me to get okay to move the slide forward. First case study is chemical plant, where some changes in the plant's processes led personnel to evaluate the feasibility of reducing a steam header pressure. Essentially, the team decided to incrementally decrease header pressure while monitoring the effects of the change on the entire system performance. Pressure was reduced twice, and each time carefully monitored to ensure there was no detrimental impact to production or system operation. The plant now operates at 100 psi, down from 125 psi prior to the change, resulting in energy savings of 8%, or an annual cost reduction of $142,000. This chemical plant is not located in Ameren territory, but if it was, it could receive incentive dollars for the project. If it applied for ActOnEnergy incentives at today's incentive levels, they could receive an incentive for as much as 50% of the project cost under the custom gas application. That's if there were any meter points or valve replacement that needed to occur with the turn down in the pressure. A second case study involves a fertilizer plant. The following three measures were implemented at this plant that conducted an assessment of its process steam system. The plant balanced its steam load by operating a natural gas utility boiler when the plant load exceeded the capacity of the two acid plants. Under certain conditions, excess steam was vented to the atmosphere in order to maximize the sulfuric acid production. The steam could be used for process steam, and it was used to replace steam generated by the utility boilers, resulting in a 10% reduction in vented steam and reduced energy consumption by 640,000 therms per year, or $295,000. They also completed a stream trap survey, which found that the annual energy reductions of 210,000 therms, or $98,000, were feasible from repairing the plant's failed steam traps. A steam leak survey was conducted at the plant. That also indicated that repairing leaks could yield an annual reduction of 12,000 million BTU, or 126,000 therms, or nearly $60,000 of associated savings. The fertilizer plant was eligible and had applied for ActOnEnergy incentives at today's levels. They could have received an incentive of up to $200,000 for all three projects mentioned, for a total of $200,000 under the custom gas and process steam trap applications. Now I'm going to turn it over to Rob to get started, or to tell you how to get started with the ActOnEnergy program.
You may be wondering how to get started on your process steam project. There are several options. The first check would be to see if you can determine what equipment you have. Find out what equipment you have, find the model numbers and performance ratings using the nameplates, cut sheets, and operator guides. An internet search of manufacturer and distributor websites can also reveal information on your equipment. Another way to get started is to conduct a survey of your steam traps to see if they are in working order. There are incentives available to conduct surveys of steam traps in your process steam system under the Steam Trap Survey Program. There are incentives in the amount of $30 to $50 per steam trap for process steam per trap, depending on the amount of pressure, and incentives of $30 per trap for surveys of your HVAC system. Complete the process steam trap application to apply for these incentives. The incentives for surveys are in addition to the incentives available for replacing components of your process steam systems. Another way to get started on your project is to contact an energy advisor. This map shows which energy advisors cover each territory in Illinois. Contact the energy advisor for your territory to speak with someone from the Act on Energy program about your energy efficiency project. Another way to get started is to contact a program ally to help you apply for a process steam project. Program allies have been trained in how the program works and have experience in conducting projects with the Act on Energy program. You can find a list of program allies on the Act on Energy website. I would also suggest you visit the Act on Energy website for more information about all of the electricity and gas savings opportunities the program offers. This is where you can find the steam trap and custom applications, sector-specific applications, and the online store. Here are some resources where you can get more information about the Act on Energy program. Please visit our website to learn more and determine which projects are right for you. Here are some other resources that may help you identify or quantify process steam system projects at your facility. I am trying to advance to the next slide and I'm having difficulty. One moment, please. There we go. Finally, here are links to the energy assessment resources we mentioned earlier.
Okay, now it is time to take the final quiz and see how much you learned today. I'm going to open that up for you, and if you could please submit your answers, you'll have about a minute. Okay, and I'm getting ready to close the poll. You have just a few more seconds. Poll will close in 3, 2, 1, and I will share the results. And I will give you the correct answers now. The answer to number 1, which of the following types of steam and hot water equipment does the Ameren Illinois ActOnEnergy program offer incentives for, is F, all of the above. For number 2, how much could repairing a single steam trap save a facility per year on its natural gas bill? The correct answer is E, over $10,000 a year. Question 3, true or false? How many low-cost steam system improvements have paybacks of less than 2 years? That's many low-cost steam improvements have paybacks of less than 2 years, and the answer is A, true. And number 4, how much of the heat generated by a steam boiler is carried away by the exhaust flue? The correct answer is B, 20% of the heat generated is carried away. So thank you very much for participating in the quiz questions. You'll be receiving, I want to let you know before I open this up for questions, that you will receive an email with a request to complete a survey about today's online training. And when you receive this email, please complete the survey to let us know what you liked about your experience today and how it can be improved. And now we're going to ask if there are any final questions for Mark and Rob. So if you have any questions, please type those into chat now and we will get those answered for you. While I'm waiting for a couple of questions to come in, to see if anybody has any questions, I wanted to let you know about a couple of webinars that are coming up in October, on October 5th, and you'll be getting communications about this to register. October 5th, there is a session about energy management systems, and that's from 8:30 to 9:30. And then on October 12th, we're going to have a session on saving money through HVAC efficiencies with Rod Rhodes, and that one is also at 8:30, once again on October 12th. Wanted to remind you again that the handouts from the presentation and the recorded presentation will be available on the ActOnEnergy website on the Education and Training page later today. And I don't see any questions. If anybody has any final questions, send me a quick chat. I don't see anything coming in, so thank you all very much for joining us, and this concludes today's presentation. Have a great day.